that software component to operate properly, both the user and the producer of that software component must obey some rules, some constraints. Preconditions are the rules that needs to be obeyed by the client of that component, by the user of that component. Postconditions are the rules, the conditions that needs to be met by whom? By the supplier, producer of that component, yeah? Just like Java methods or C methods. Once you use a method from the library of C, you have to make sure that you put the correct parameters to that method, yeah? That's the precondition. If you do not put the correct parameters, then that method will not be able to work properly, will not be able to work as intended. Once you put the parameters correctly, this means that precondition is satisfied. You as a client perform the satisfy the precondition, then the method itself guarantees you that, the developer of the method itself guarantees you that the method produce the correct result. Yeah, this is the post condition. This is what the developer of the method needs to obey. Once you give the correct parameters, the developer of the method guarantees you that the result will be correct as well. So that's what contract is basically. So we apply contracts to the specification of components and connectors. The methods and events of component ports are specified in terms of two types of contracts. These are interaction contracts and functional contracts. So each event, each methods are attached with two types of contracts. Here, interaction contracts represents when that method can be called, when that method can be operated, when, for instance, here in the screen you will see a server port. Server port includes a single method called request method. There are two different types of contracts attached, interaction contract and functional contract. Here, interaction contract states that the request method can be offered to the component environment only when the initialized data of the component is true. Once you offer your method to the component environment, then the functional contracts comes into the stage. Functional contracts update the state in the way specified. Their responsibility is to change the component state after you perform the method operation. Yeah? So realizability, we already handled realizability in XCD. We guarantee realizable specification. So any architecture specification described using XCD are guaranteed to be implemented in the same way they are specified. So if you need further information, there's a paper that describes how we ensure realizability. Yes, another important thing is XCD supports formula analysis automatically. So you can analyze your XCD architectures automatically. Yeah? By doing so, you can identify a number of design errors, which I listed here, such as wrong use of component services, wrong functional behaviors of components, wrong interaction protocols of connectors, and so on and so forth. So to do so, what we've done is we produce some compilers. We produce some compilers that translates any XCD architecture specification into process algebra models. Because these process algebra models are supported with analysis tools, once our compiler performs the translation from XCD to process algebra, then designers can use these analysis tools to perform their architectural analysis, to identify the mistakes in their software architectures. We later on do the same for a separate process algebra. So we provide two different compilers that produce two different process algebraic models, because each process algebraic model has their own analysis tools, some of which is more powerful than the others. Having done that, we analyzed, we evaluated our approach, we evaluated our compilers and also the language syntax semantics itself in terms of several real system case studies, such as Aegis Combat System, gas station, lunar lander, English auction, and nuclear power plant system. Yes, so we have a research group that has just been established in our university, and this research group just focuses on improving XCD nowadays. So now our main focus is to improve this language to a further point. What we are doing currently is we are producing a GUI editor. So using this GUI editor, software architectures can be specified visually as well. So currently, the XCD only offers textual notation, but our group now works on building some new set of notations through which designers can specify their software architecture visually. Yeah. So to do so, we already constructed two different teams that work closely to each other. The first team builds the architecture diagram editor itself, and the other team works on the compilers. So the compilers here are used for the purpose of translating any visual notation, any visual specification into textual specification, and vice versa as well. Because that's how we can make architectural specification, visual specification analyzable. Yeah, currently we only support the analysis of textual notation. That's why we need compilers. We need to translate any XCD visual specification into textual specification. That's why we need compilers. Yeah. So that's what we are doing currently in university. Yes, questions? Yeah, I finished early. Yeah. Do you have any questions? Of course you have. Soru var mı arkadaşlar? Any question you have? Don't be shy. Yes, Hamza.
How do you show
The synchronization. Say how we satisfy synchronization. Yes, synchronization is outside the scope of XCD, but synchronization is quite important in the sense that if you are working on a concurrent system, you must make sure that the components of these systems synchronize with each other properly. But XCD focus more on the distributed systems, not their concurrency itself. So synchronization is completely about concurrency, which is outside our scope currently. But we can improve XCD in the future to support synchronization as well, to support the synchronous communication of components. Just like what? DNA, yes.
Yeah, actually, I guess that the biological mathematics is used in that way. So
Yes, exactly. Yes, yeah. To some sense, what you said is sensible. Yeah. I mean, we make people. Yes, exactly. We make people specify their architecture in terms of components interacting with each other through some connectors. Yes, we have some components, we have some elements, just like existing in DNA. Yeah, that's a good approach. Yeah. Yes. Yes.
Do you think that when these kind of creators become common in the software field, people will drop UML and
That's our goal. I mean, that's the goal. That's what we aim to do. I mean, by developing graphical user interface for our language, our goal is to attract the attention of industry. Our goal is to make industry use our language. That's our precise goal here. I mean, that's why we intend to enhance the usability of our language by making it visual, because we know that people use UML, which is visual. Yeah. But that's just the goal. There is, of course, no 100% guarantee that they will just shift UML from our language. But that's just a hope. Yeah. So, any other questions? No question? That's it. Ha?
uygulamada daha çok zor oluyor yaparken.
Evet.
Anlamasını anlıyoruz.
Güzel. Uygulamasını da yaparız bir ara. Tamam o zaman. Bitirelim arkadaşlar o zaman. Tamam.